So I had a request just to go through Cramer's rule again. So Cramer's rule is a way to solve systems of equations. So we're going to solve the following system. You can pause to read it over. We're going to solve this system by Cramer's rule. So for this system, so remember that most systems can be written in this form AX equals B, where A is our coefficient matrix. So what I'm going to do is I'm just going to take all the coefficients that I see here and I'm going to put them in my matrix A. So for X's I have 1, 2, 4, 1, 2, 4. Y's I have negative 3, negative 1, and then there's 0 Y's here, so negative 3, negative 1, 0. And then for my Z's I have 1, 0, and negative 3, 1, 0, negative 3. And then the other thing that I'm going to need for this is that I'm going to need the B column, so that's going to be the answers, 4, negative 2, 0, 4, negative 2, 0. Okay, so now Cramer's rule really just depends on you knowing what the formula is. So basically for the first solution, you're going to use the determinant of A sub 1, and that's going to be related to matrix A. So I take the determinant of A sub 1 divided by the determinant of A. For Y, I take, so that's the second solution. So I take the determinant of A sub 2 divided by the determinant of A. Z is the third solution, so I take the determinant of A sub 3 over the determinant of A. So let's talk about what are these A1, A2, A3 things. Okay, so let's go back to looking at this information. So of course you can tell that you need to know the determinant of A. So one thing that I'm going to say is I'm not going to go through finding determinants in this video because I think that that's a skill hopefully you know when you're doing this. So the first thing I'm just going to do is I'm going to use technology. I use technology to find the determinant of A. So just an FYI, the denominator for all of those is negative 11. So now what about the other matrices? Okay, so for A sub 1, so that is talking about the first column, and I'm going to replace this first column with my B column. And then for A sub 2, so then I'm going to take the second column and I'm going to replace it with B. And then for A sub 3, so then the pattern just continues. So I take the third column and I replace it with B. So that's what I need to do each time. And then I find the determinant of each one of those matrices and you get your solutions. So first, let's just focus on X for a moment. So if I wanted to find that A sub 1, so remember, I'm going to take this column now and replace it with 4, negative 2, 0. So here's what my matrix A sub 1 looks like. So 4, negative 2, 0, everything else is the same, okay? And so now I just need to go through and I'm going to use technology to find my determinant. So my determinant of A sub 1 is 30, and I already know my determinant of A. So then to find the solution for X, so I'm going to take the determinant of A sub 1 divided by the determinant of A. So 30 over negative 11 is going to be my first solution. And so I can continue this for the other two. So just to be nice and explicit, so my A sub 2, so notice now here's my B column, so everything else in the matrix is the same, but I replace that middle column with 4, negative 2, and 0. And then same thing for A sub 3, so now I've replaced my third column with 4, negative 2, 0. So these are the two matrices that I've created, and I just need to go through and I use my technology to find the determinant of each. So the determinant of A sub 2 is 38. The determinant of A sub 3 is 40. So then I just plug everything in. So for Y, I take the determinant of A sub 2 divided by determinant of A. So that's going to be 38 over negative 11. And I do something very similar for Z. So I take my determinant of A sub 3, which was 40, over my determinant of A, and that's 40 over negative 11. And so that's how you use Cramer's rule. And it's really important, I think, in this to use technology. It just makes it so much easier. So if you found that helpful, I'd love you to hit that like button or the subscribe button. And otherwise, I will talk to you guys in another video. Bye.